Section 16.12 deals all the reaction. Now, this is going to be a first reaction that's going to be completely different than the ones we've seen before. The last couple reactions that we're looking at were reactions that were really just addition to alkenes that we'd seen before, and we just were looking at what was interesting about how that works with a conjugated diene versus an isolated diene. So for a Diels-Alder reaction, we need two pieces. We need a diene, and then we need some kind of a dienophile, or something that wants to react with the diene. And we heat the reaction, and what happens is we get a new cyclic structure. So let's look at the overall mechanism for how this is happening. Diels and Alder actually shared the 1950 Nobel Prize for helping people understand the intricacies of this reaction. What happens is a pair of electrons from the diene come out to react with the alkene, which pushes the pair of electrons from the alkene towards the other end of the diene, and then the following pair of electrons from the diene move to where there used to be the single bond between the two alkenes. So if I look at my reaction product, I'm going to draw each new bond with a dashed line. So what we did is we made two new sigma bonds, and one new pi bond. Okay, so those are the new bonds that are formed. The common features of a Diels-Alder reaction are one that's initiated by heat, and that's why you can see the triangle up here. Two, you form a new six-membered ring. Three, there are three pi bonds that break, and two sigma bonds and one pi bond form. So you should actually be able to figure out whether the product is going to be lower energy or higher energy than the reactant. And just in case you couldn't figure that out, I'll tell you that if you remember, sigma bonds are stronger than pi bonds, so we're forming two stronger bonds than the one that we're breaking. So our product is going to be more stable than our reactants are. And the last part is that the mechanism is concerted, not stepwise. So all three of those electron pairs move all at once to make the product. Okay, so let's look at a couple examples of Diels-Alder reaction. So we do the same thing, draw the mechanism. This pair of electrons comes out here. This pair of electrons goes up to form a new sigma bond here, and this pair comes over to form a new pi bond. So here's our six-membered ring. And there's the aldehyde. Okay, our new bonds are here, here, and here. So how do we draw Diels-Alder reactions? First, we need to arrange the diene in the S-cis conformation. If you look at how the electrons are always moving to form a new ring, if they're in an S-trans conformation, it's not in the shape of the ring already. And so the reaction actually won't occur. So first of all, it has to be able to rotate, which is rotation around the single bond in between the two alkenes, to make the S-cis conformation. Next, you want to place your diene and dienophile near each other so that it's almost in the shape of a six-membered ring already. So if you see here, if I just drew those dashes there, that would make it into a six-membered ring. So it's already close to being a six-membered ring. And then third, you want to cleave the three pi bonds using arrows to show electron movement and draw in the new bonds that are forming. And so far I've been doing it one specific way. It actually doesn't make any difference whether you draw the reaction going clockwise or counterclockwise. So I can draw the electron pair coming out from the diene this way, pushing this pair down to make my other new sigma bond, and pushing that pair over to make the pi bond.